right, 4.7, complete the square. So the key phrase for this is half the middle term and square it. You can remember that, you'll be good. So this is basically a way that we're going to be solving a quadratic equation where just simple factoring does not work. So you will not be able to factor. Sometimes the book actually gives you one that you can factor, but if it says to complete the square, you have to complete the square. Okay. And then if this method for some reason didn't work, you would have to use the quadratic formula, which I think we did right before Christmas, but I don't honestly remember. So anyways, so if you had something like x squared plus bx plus c is equal to 0, and notice you cannot have a number in front of x. So if there's a number in front of x, we cannot complete the square, and we would have to use the quadratic formula. So what we would do is we have x squared plus bx. We have to move this over because we're trying to replace this term to make this something that we can factor. Okay, so we're going to move it over. And yes, there's a reason I left a gap. So this is where we say we add a box to both sides and we have to fill in the box. Okay, we're trying to make the left side a perfect square trinomial. So something that will factor into the x plus or minus whatever the number is, the whole thing squared. That's what we're trying to force to happen. This sign here could be negative also, just that's going to be the difference in if your parentheses is positive or negative. So we half the middle term, so we take half of b and we square it. So it's going to be in this box b over 2 and that whole thing squared. And what we do to one side, we have to do to the other. That's why I put the boxes there, so that you remember, like, I did this to the left side. I also need to put it on the right side, so we would also add the b over 2 squared to the other side. So then, like I said, we wanted our perfect square trinomial, so now this factors into x plus b over 2 and that whole thing squared. Now, sometimes it's nice and it ends up being something such that you can reduce it down, where like b would have been like 4 or something, so it reduces nicely and you don't need to leave it as a fraction. What you will notice that I do a lot on the left side is that I will actually leave it as whatever that number is squared, but on the right side I will go ahead and actually square it, because you're just going to be combining this. So this is equal to negative c plus b over 2 squared with whatever that ends up being. So yeah, I usually will just leave this one because it's ultimately what's getting copied down, so there's no reason for me to multiply it through. Because then you're sitting there, well, what is this the square of? Like, it's just easier. So we're going to do several examples of this, just because, like I said, it is kind of a confusing topic that tends to just cause problems, even though it really shouldn't. It just does. So, and I'm speaking from experience. Like, it took me forever to understand completing the square. Like, seriously, pre-calculus before I actually understood what I was supposed to be doing. So let's start with some examples. Number 4. Solve the equation. Oh, well, these say by finding square roots, so we may or may not actually have to complete the square first, but we'll see. X squared plus 10x plus 25 equals 64. So since these ones don't say we have to complete the square, we can see if they're factorable first. So does the left side factor?
Yes.
Okay, into what? Or what is this?
That's a perfect square trinomial.
So this is a perfect square trinomial. So basically they've already done the first step for you, kind of how you can think about this. So what does this factor into then, if it's a perfect square trinomial?
X plus 5 squared.
Yep, x plus 5 squared is equal to 64. Now it says solve by finding square roots, so what do you think we need to do next? Square root of both sides. So x plus 5 is equal to what?
8.
What happens if you take the square root?
Positive or negative.
So plus or minus 8. So then, because this is going to give you two completely different numbers, my lunchbox was moving. We need to split it. So x plus 5 equals 8, or x plus 5 equals negative 8. So then x is equal to 3, or x is equal to negative 13. And so with completing the square, basically that's what's ultimately going to happen. So essentially, they did the completing the square step for you in these ones. So it's kind of nice that we have this as like a little bit of a review before we actually get going with them. So you're completing the square problems should always have two answers. Now, whether or not it's written as two, because if it had a square root, we can just combine it. But it would technically have two answers. Let's see. Let's do another one like that. Number 8. X squared minus 18x plus 81 equals 5. So what does the left side factor into?
X minus 9 squared.
X minus 9 squared equals 5. Now what? And what does that give you?
X minus 9 equals plus or minus 5.
Square root of 5?
Square root of 5.
And so then we just need to move the 9 over. So x is equal to 9 plus or minus the square root of 5. And since it is in a square root, we can leave it all as 1. But still, technically, that does give us two answers. All right, so the next ones say to find the value of c that makes the expression a perfect square trinomial. Write the expression as the square of a binomial. So basically, we're just finding the number that when we're finding this c term here now. So 14, we have x squared plus 12x plus c. So I want to find what c is first. So we take this middle term and we half it. So 12 over 2. And then we square the whole thing. So that's going to be 6 squared, which is 36. So c is equal to 36. So that's the first part. Then it wants us to write the expression as a square of a binomial. So basically, replace c with 36 and factor it. So x squared plus 12x plus 36 would factor into what?
X plus 6 squared.
X plus 6 squared. So with a problem like this, you have to have both pieces for it to be completely right. Um, 16, we have x squared minus 30x plus c. So how do I find c now?
You split negative 30 in half and squared.
Yep. So yeah, so technically, it was kind of good that you pointed that out. So you said the negative 30, because I don't think we've actually had a negative one yet. So You will not often see me write the negative sign when I do it, simply because when it's getting squared, it's going to result in a positive. But technically, yes, it is the negative 30 halved and then squared. But if you don't see me write it, that's why. Okay, don't think that you get a cookie point off of me not writing it. Okay. But yes, just don't forget that the whole thing's getting squared, so it is going to go away. So that last term's always going to be positive, or it won't be a perfect square trinomial. So this ends up being 15 squared. Does anybody know what that is off the top of their head?
225. Yes, I do.
It's okay. I was not expecting anybody to know that.
Me
So
I'm like, in my head, I'm like, okay, well, 10 squared.
I'm like, usually once I get to 13 squared, I'm like, I don't expect him to know anything past that. All right. So then to write it as a square of a binomial, what would that be? Or here, I'll rewrite it like this first so that you can see it. Well,
X
I guess technically this is, hold on, there.
I was gonna say, that's not right.
Well, I was sitting there and I was like, okay, what do I need to do? I need to write a square, but I could not bring myself to write this square. It's like, what is happening? Yes, x minus 15 squared. That's what happens when you're coming back from 20 hours of driving. We got back at like 10 o'clock last night, so I'm pretty tired. And then had to play a whole volleyball tournament the next day.
Yeah, but you know what? You gotta do what you gotta do.
All right, 18, x squared plus 50x plus c. So how do I find c?
50 divided by 2 squared.
50 divided by 2 squared, or 25 squared. Anybody know that one off the top of their head?
Nope.
All right, it's 625.
Wait, do you
I knew
know
there
that
was-
one off the top of your head?
No, I have it right
Oh,
now.
okay. I was like, you know that one, but not 15?
I knew there was a 6 somewhere.
Well, I do end up using them a lot, especially when I start doing factoring in multiple classes. I do end up using them a lot, so I do remember them for a while, and then I'll just go and forget them again. So, anyways, all right. So then square of a binomial. So we have x squared plus 50x plus, if I can get it right this time, 625. So then what is the square of my binomial?
X plus 25 squared.
Yep. So that part's not too bad, right? So normally everybody does really, really great up to here. And then when I add the right side of the equation, everybody's like, literally it's this plus the first set of problems that we did combined. And that's all completing the square is. But for some reason, it gets really scary when you put it all together and people are like, I don't get it. So, warning you, we're coming up to the next step now where we're doing all of it together. But don't let it scare you. It will be fine. So, these ones actually say to solve the equation by completing the square. So, the first ones are set up nicely for you. You don't have to move anything. You don't have to do anything. It's already nice. So it's x squared plus 4x is equal to 10. When they do write them like that, I will usually just go ahead and leave a space and I will just fill in my box from there. So I'm going to add a box to both sides, remember. What I do to one side, I have to do to the other. So 2 boxes. So ignore the right side for right now. How would I find my box term?
Split 4 in half and square.
Okay, so half of 4 is 2, so that would be 2 squared. So again, on the left side, I will often write it like that, just to help me see it. On the right side, I will go ahead and square that number. You don't have to. You're more than welcome to write it the same way. I just like to do that, and I think it makes it a little bit easier. So I will go ahead and write that as 4. So again, ignore the right side. What do I do with the left side to factor it?
It's the perfect square trinomial.
So what does that
X plus
factor
2
into?
squared.
Okay, x plus 2 squared equals, and then 14. Now, we're back to first set of problems. So what do I do next?
Square root.
Square root.
Yep, so square root of both sides. So x plus 2 is equal to plus or minus the square root of 14. Can anything come out of that square root?
No.
No. So if something can come out, I do want you to take stuff out. I didn't mention that earlier. But this one can't. So then I would be able to leave it all together. So it would be x is equal to negative 2 plus or minus the square root of 14.
I love that one.
All right. Let's do 24. X squared plus 6x minus 3 equals 0. So if you have one like this, okay, initially your first reaction might be, well, let me check and see if I can factor it. And that's great. That's normally what you would do. If I just told you to solve the equation, I didn't tell you a method, you might be like, well, I want to factor it. Well, this one can't be, but let's say it could be. On a normal day, sure, you could factor it. These say complete the square, we have to do that. So right now we have a problem because this is over here. So I need to move this over to the other side first and then do my box. Okay, so we would have x squared plus 6x plus box is equal to, I moved the 3 over, so 3 plus box. So I need to figure out what's going in the boxes now. So what would go in my box?
3 squared.
3 squared, so half of 6 is 3, and we square it, and then on the other side I will go ahead and write that as 9. So what does that factor into on the left?
X plus 3 squared.
X plus 3 squared equals 12. So then square root of both sides, which is x plus 3 equal to plus or minus. Now, square root of 12, can I take anything out?
2.
I can take out a 2, and that leaves me with the square root of 3. And then again, because there's square roots included, I can just write it as x is equal to negative 3 plus or minus 2 square root of 3. Now, I think we had a brief encounter with i's prior to Christmas. So that can happen with these problems as well. If you end up with a negative under the radical, all you do is just take the I out front. So I'm going to do one like that really quick. So 26, we have x squared minus 18x. Is my door locked? Plus,
Do you want me to unlock it?
yes, please. Thanks. It's like super weird because like when I left for break, I didn't push the thing in and turn it. So it's like I don't know.
It's the Holy Spirit. That's what it is.
I guess so. It's to lock me in my room. All right, so again with this one, I need to move that C term over so that I can actually get something that completes the square. So I'm going to have x squared minus 18x plus box is equal to negative 86 plus box. So what would go in the box?
-9 squared.
Okay, -9 squared, or just 9 squared as I'm going to write it, which then is 81. So what does that factor into on the left? X minus 9 squared is equal to -5. So now when I take the square root of both sides, I have x minus 9 is equal to plus or minus. Because I have a negative under the radical, I have to take the I out. So we would write it as plus or minus I root 5. And then we have x is equal to 9 plus or minus I root 5. And you probably remember me being very like, it has to be in standard form, the I goes at the end. Normally I do say that, however when there's radicals involved, I will typically write it in front because that way it doesn't look like it's underneath the radical and get confusing. And these ones don't say they have to be in standard form, so that's also why you can leave it that way. Alright, let's look at one more. 32. We have 7t squared plus 28t plus 56 is equal to 0. Now, what do you notice about this one?
You can take out a 7.
Okay, so first of all, at the current moment, I cannot do completing the square because there's a number in front of my first term. Okay, if there's something there, I can't do it. But what I can do is see if that number can come out of everything else. And if it can, then I could proceed with completing the square. So I can take out a 7 from everything. So we would have 7 times t squared plus 4t plus 8 equals 0. Now, because then we would divide by 7, 0 divided by 7, it goes away. If there was a number, hopefully it can divide by 7, because if not, that's going to make your math absolutely miserable if it's like a fraction. But it's gone, so we have t squared plus 4t plus 8 is equal to 0. Again, remember, sometimes when you get there, factoring is a possibility. And so if it says complete the square, you have to complete the square, okay? Now you say, why does she keep saying this? But it's happened. I told somebody that they had to complete the square, and what did they do? But they factored it. They're like, well, I could factor. I don't care. I don't care. So how would I proceed with completing the square? Like, what would I need to do now?
Move the 8 over.
Move the 8 over, so t squared plus 4t equals -8. I'm going to add my boxes to both sides. And what goes in the box?
2 squared.
2 squared. Or 4. So what does that factor into on the left?
T plus 2 squared.
T plus 2 squared is equal to -4. So then square root of both sides, t plus 2 is equal to plus or minus, what's that? 2i. And so with the I, you're welcome to go ahead and leave it together as well. You don't need to split it unless you just really want to. So t equals -2 plus or minus 2i. Any questions so far about that? Usually the questions end up coming more when you start doing them really yourself. So I'm going to give you a few of them to do. If you feel confused, I would say do more. I'm only assigning one of each of the like first step problems. I would say if you feel like you are confused, maybe start and do a few more of those as well. But 5, 15, or actually I guess I'm assigning 3 of the first step problems. 19, and then 23, 25, and 33. Actually, scratch that. Do 31 instead. 33 is kind of mean. It's got multiple fractions in it, and that'd be kind of rude. So, day 1 back. Try to give you some nice problems.
Chapel it, or